Welcome back to the deep dive. So, lots of you have been asking how these large language models, LLMs, actually create those responses that sound, well, pretty smart.
Right. It seems like magic sometimes, doesn't it?
It really does. We've got some notes, different perspectives here, and we really want to, get under the hood today. It's not just about predicting the next word, is it? We want to figure out what's going on behind that feeling of actual understanding.
Exactly. People are curious how algorithms spit out text that feels so coherent, sometimes
Yeah.
even insightful. And yeah, we've got info on their capabilities, but also their limits, especially with things like reasoning and moral judgments, plus viewpoints from different researchers.
Okay, let's dive right in. How do they generate these responses? I mean, it can't just be picking words randomly.
Well, no, not randomly. It's fundamentally about prediction. Predicting the next most probable word based on, well, just vast amounts of text data they've been trained on.
Probability, okay.
Yeah, so when you give it some text and input, the LLM looks at it and uses these billions of parameters, think of them as learned connections, to figure out the most likely sequence of words to come next.
Billions. Wow. So probability is really driving it all. But hang on. What about when they seem to reason? That feels like it's got to be more than just guessing the next word.
That's a really crucial distinction for you to grasp. LLMs don't reason like we do with understanding and consciousness. They simulate reasoning
Simulated.
by recognizing and essentially reapplying patterns they found in all that training data. They can sort of mimic deductive logic if they've seen examples, or inductive logic by generalizing from patterns. Even common sense, like water is wet, is usually just a very strong pattern in the data.
Okay, pattern matching. We've got that example here, the math problem. Roger and the tennis balls. How does that illustrate this?
Right, the tennis ball one. Rogers has 5 tennis balls. He buys 2 more cans. Each can has 3. An LLM solves this, probably correctly.
Yeah.
But how?
No.
It's seen countless problems structured just like it. It recognizes the pattern. Starting number, addition, multiplication. It applies the learned sequence of operations based purely on that pattern recognition. It doesn't understand Roger or tennis balls.
Got it. So, sophisticated pattern matching, that looks like reasoning. Okay. Now, what about something trickier, like morality? Do they have any sense of right or wrong you should be aware of?
Morality. This is where it gets really, really different from humans. The short answer? No, not like we do.
Oh,
They lack personal experiences, emotions, ethical frameworks built over a lifetime. Those are, pretty fundamental to human morality.
so when it says something like hurting animals is wrong.
It's reflecting what it learned. It's recognized a very strong pattern in its training data that associates hurting defenseless animals with negative sentiment and wrong. It's echoing the dominant human viewpoints it was trained on.
It's echoing the data. So what if you gave it a really tough moral dilemma, like that classic save one loved one or 5 strangers scenario?
Good question. It wouldn't make a personal choice because it has no personal values or loved ones. What it would likely do is outline the different philosophical perspectives it's learned about.
Oh, okay.
It might present the utilitarian argument, save the most lives, or it might discuss the emotional or perhaps cultural reasons often given for saving a loved one. It presents the patterns of argument it found in the data. It doesn't feel the dilemma or make a choice based on internal values.
That really highlights the difference, doesn't it? We have this comparison table here, human versus LLM intelligence. What are the key takeaways for listeners? What should they keep in mind?
Well, the big ones are humans understand context through lived experience and emotion. LLMs process patterns and data. We reason using logic, intuition, and feeling. They use probabilistic calculations that mimic logic.
Right. And morality.
Our moral judgments stem from deeply held values and empathy. Theirs are statistical reflections of societal views in the data. We adapt creatively, sometimes on the fly. They adapt by finding the closest known pattern. Our creativity can be truly novel. Theirs is mostly remixing existing data. And, critically, our decisions in complex situations involve all that internal stuff, emotions, social understanding, which LLMs just don't have.
And I see Apple's research mentioned here. It seems to back this up, this idea of pattern reliance.
Exactly. Apple's work, and others too, shows that LLMs can be brilliant at tasks very similar to their training data. But you make even a small, logical tweak to the problem.
And they can stumble.
Precisely. They falter because they were relying on recognizing the exact pattern, not on flexible, underlying logical reasoning. The GSM symbolic benchmark they mentioned is a good example. Change the symbol slightly in a reasoning task, and performance drops. It really underscores the pattern-matching nature over true logic.
Okay, so wrapping this up. The main thing for you, the listener, to understand is that LLMs are incredibly powerful text generators. They mimic intelligence really well by leveraging patterns from enormous data sets.
That's the key. They don't understand concepts, they don't reason flexibly like humans, and they certainly don't have genuine moral understanding. Their intelligence is advanced prediction and synthesis based on learned patterns.
Not true comprehension in the human sense.
Not at all.
Right. So thinking about these fundamental differences, these limitations, here's something for you to mull over. What does this mean for how we develop AI responsibly? How do we use this powerful but ultimately pattern-based technology going forward, knowing it's built on such a different foundation from us? Definitely something to think about. Thanks for joining this deep dive.